Hey, hello everyone. Welcome to the Understanding Pre-Painted Metal webinar. My name is Paul Deffenbaugh. I'm the editorial director at Metal Architecture magazine. We're having a couple of technical difficulties. Our presenter needed to reboot her computer, so if you'll just hold on with us for a moment, we'll get things sorted out and begin the presentation. Thanks very much, and I appreciate your patience.
Oh.
Hi, everybody. It looks like Michelle has come up. Michelle, we're live. We'll sort things out here kind of in live time.
I'm still having technical difficulties on my end.
So everybody's going to get to see our underskirts. Here's what we'll do, Michelle. I'll share my screen and we'll just do the presentation from my screen and you can do the next slide thing. Does that sound good?
Okay. The other option, I was able to get a PDF copy to open. If you want me to use that, so we don't have to do the next slide.
That sounds fine. When you're ready, I will share. I will give you the control over the screen.
Okay, I am ready.
Thanks everybody for being so patient on this.
Yes, apologies. Okay. Can you see the opening slide?
That looks good, Michelle. So let me start from the top and thank everybody for joining us today on the Understanding Pre-Painted Metal webinar presented by Steelscape. It's another in our series of webinars from Metal Architecture magazine. And as I said before, I'm Paul Deffenbaugh, I'm the editorial director. Michelle's going to start in just a moment, but let me give you a couple of things about how we're going to proceed. This is an AIA certified course, and you'll earn 1 HSW learning unit. Reporting will be handled automatically, but please give us 7 business days. 7 business days to handle that process. And for those people looking for certificates, they'll be handled automatically as well. Again, 7 days. Look, we want to hear your questions during the webinar. You can use a panel on your screen to submit them. And at the end of each section, I'll bring up your question with Michelle. And honestly, she is just a fabulous resource. So you don't want to miss this opportunity. Michelle is the technical manager for NS BlueScope Coated Products North America. She graduated from California Polytechnic State University, San Luis Obispo with a Bachelor of Science degree in chemistry. She started her career as a research chemist with Morton, which later became BASF Coil Coatings, with a focus on polymers. And this position also included lab development as well as lab to production, scale up, and manufacturing quality and process control. Eventually, Michelle shifted to cool pigmentation, where she brought the first cool coil coating to market. She's been active in the Cool Roofing Rating Council and Energy Star Roofing Program. She joined Steelscape as a quality engineer for the Rancho Cucamonga, California paint line. And while there, she's held the quality systems manager role and is now technical manager. Michelle oversees the quality systems and technical service for BlueScope Coated Products North America, which is comprised of Steelscape and ASC profiles. She's an active member of the National Coil Coaters Association. She sits on the technical committee as well as the Zinc Aluminum Coaters Association. And I should add that we often turn to Michelle for her expertise in the magazine, so you may have seen her regularly in some of our features. Michelle, thanks very much. Looking forward to hearing what you have to say.
Thanks, Paul. It was quite the introduction. Appreciate it. Apologies again for the technical difficulties. The presentation I have up may be a little bit different than what we would normally present, but you'll still get your credit and it's still the same content at the end of the day. So thanks for bearing with us. So again, it's 1 credit. That contact information is actually not correct, but again, your certificates will be handled and we can get you in the right hands if there's follow-up on that. So these are the 4 areas we're going to cover today. Understanding pre-painted metal fundamentals, the paint application process, and why we use this process and its advantages. And we're going to talk about the paint systems themselves. That's sort of the meat of the presentation. We'll go over the 3 main types of paints, what their differences are, when and how you'd want to use them, and what the appropriate applications are. Then we'll talk about enhancement options for like specialty installations like marine or industrial. And then at the end, we'll talk about durability, warranty considerations, and taking care of this product long-term. So what is pre-painted metal? Well, it's pretty self-explanatory, right? It's metal that's painted before it's formed into its final pieces and parts. So it can be steel, coated steel, or aluminum usually in the construction world. The paint is baked on in a factory setting, a very controlled environment. In coil form, and then the coils go off to be formed into panels, trim, flashings, whatever that needs to be, right? So this is very different than other construction materials that typically are installed and then painted in situ. This allows us to have a very efficient production operation and a very tight quality controlled setup as well. Good easy for me to say, reproducibility. And of course, a huge array of colors and options on the aesthetic side as well. However, not all pre-painted metal is the same. You know, the substrate and the coating certainly plays a part in what kind of performance you're going to get and how it looks out in the field. So pre-painted metal fundamentals. So this is, sorry, Paul, we are missing slides on this version.
Would you like me to pull up my version and run from that? Jennifer or Michelle, I will pull up my presentation and we can run from that.
Yeah, sorry guys.
All right, does that work?
I don't see your screen. Do I need to stop something on my side or?
You should be able to see it now. You'll need to switch from your screen to the.
Okay.
Got it? All right.
So I am
Thanks,
on
everybody.
the, I don't know what slide number it is. It's the spotlight question. First one. Couple slides in. Next one. There we go. Okay, back on track. So the spotlight question, how is paint applied to metal for the majority of building applications? Is it airbrushed, dipping, rolling, or brushing? Next slide. And it's rolling. So, right, we use giant rollers. There's a picture of what a continuous paint line looks like on the coater head. That's how paint is applied with giant rolls that touch the strip. It moves very, very fast. Next slide. So how do we do this? This is a schematic, the NCCA from the National Coil Coaters Association of sort of a generic paint line, what it looks like. You can also go to the NCCA site and look at videos and stuff too, which I recommend to get a feel for the scope and the size of this. These are large lines, move very fast. So it's a continuous process. We load coils at one end, they run continuously through to the other end, we recoil them back up. It's cleaned first through a cleaning section, gets a pre-treatment put on, then a primer coat, and then a finish coat. It's baked on. Most paint lines are running anywhere from 100 to 700 feet per minute at this point, which is quite fast. Curing process of the paint, from the time the paint is applied to the strip to it's cured and dried, is anywhere from 15 to 30 seconds. So very, very quick. In comparison, we always use analogies to car manufacturing, car paint coatings, because people have a feel for that. Cars can take anywhere from 30 minutes to 2 hours to be completely coated. You know, we can run enough coil in a matter of minutes using our process to do many, many buildings. So the scale of economy is quite large. It is the fastest and thinnest coating process in the industrial coatings world. The paint thickness is a fraction of what a paper thickness is. So we're applying it very, very thin, which is hard to wrap your head around. But paper is a couple times thicker than the paint that we're using. Next slide. So again, I know typical paint system total, both sides is 1.4 mils. You know, by comparison, other types of industrial coatings are 2 to 5 mils in thickness. And then this coating, right, it has to withstand the fabrication process into the panels or building products it's going to be made into. So they have to be hard and durable, but also flexible and forgiving too. So a lot of chemistry that goes into that at the end of the day. This is a controlled environment, again, so we get reproducibility on color and film control. Closed loop system, the curing ovens capture and burn any VOCs that are in the paint system. We actually use that. Most lines are using those VOC burning to refire the ovens and heat the ovens, so it's closed loop. So sustainability is very good. Next slide. However, there are some limitations that come with this. That's a picture of a steelscape line there, actually, so you can see how large they are. These lines hold anywhere from 1,500 to 4,000 linear feet of steel at one time from end to end. So, you know, the scale of economy is great. We can run a lot of product very quickly, but this makes it tough to do very small orders, custom orders. So it can constrict the color palette a little bit and the finish that you get. You know, if you want really small orders or small custom work, it can be long lead times and result in increased cost as well. Next slide. So the quality control that we do off the paint lines very much mimics or tries to mimic the forming and fabrication that's going to take place downstream, right? So we do a T-bend, we bend the metal back on itself with the anticipation that there won't be any cracking or fracturing of the paint or the substrate. We do impacting from both sides, right, to test the paint adhesion, how well the metal holds up to that. We do color validation, which is mostly computer controlled numerically. We measure the gloss and the sheen of the strip, and of course we measure film, which is really critical to the warranty performance long term. So we measure that across the width of the strip as well. Next. So when we're done, we've got quite a few layers going on in the final product. So you have your base metal in the middle there, which is the majority of the thickness of the final product. So if it's a coated steel product, it's then going to have a metallic coating of either galvanized or galvalume, which is the zinc aluminum coating on it. Then the very thin layer of pre-treatment to help promote adhesion for the paint system. And then your primer. Your primer does a couple of things. It provides a lot of corrosion protection, but it also preps the surface for that top coat, so you get nice even coverage and color. And again, good adhesion, good flexibility can come from your primer as well. And then of course your top coat, that's the part everyone's going to see. So that's the aesthetic and design portion, which is very, very important in the end product. You may have some optional coatings like clear coats, depending on color and if it's an industrial or marine environment. You might have to add a clear coat, but majority of painted product for the construction industry does not need that clear coat. It goes out with just its top coat. Next slide. So metallic coatings, I want to talk about this a little bit because it's really important in the final performance of the product, right? So it's either hot dip galvanized, which is 100% zinc, or it's a 55% aluminum zinc product, also known as Galvalume or Zincalume in the industry. You've probably seen those names. Those common coated steel that's out there. Of course, aluminum, we do coat aluminum as well. It has great corrosion protection. The Galvalume product, the 55% aluminum zinc product, is the next best for corrosion protection and does come with a substrate corrosion warranty from most suppliers, whereas your galvanized or 100% zinc product will not. A note here that Galvalume and Zincalume are registered trademarks, and you also have to be licensed by the BIC Inc. to call your product by these names. So it is a licensed product. Next slide. So why do we do this? Well, it's all about corrosion, right? We all know that steel doesn't hold up real well out in the real world unless it's got something over it. So on the Zincalume or Galvalume product, you got two things going on. The aluminum portion provides a inert protective barrier, whereas the zinc is a sacrificial barrier. So the zinc will corrode away preferentially over time to protect the steel, whereas the aluminum stays in place and is fairly inert long term as well. Like I said, the BIC licenses coaters to make this product. Most producers are offering anywhere from a 20 to a 25-year warranty for corrosion perforation on this product. There's some exceptions, of course, near the ocean and in industrial environments. So you do need to read those warranties carefully and make sure you're getting the right product. Next slide. So what is paint? Well, I think we all know what paint is, right? We've all done painting of our own at some point, either as a child or as an adult. It's a liquid designed for application to a surface in a thin film, cures to a solid film, right? You want it to protect the surface and you want it to create a desired aesthetic. You want it to look a certain way, right? And we talked about that brushing, dipping, spraying, vacuum coating, and rolling are the most common. In the coil coating world, it's rolled on. Next slide. So the primary components of paint are, there's four: resin or polymers, that's the binder of the paint, that's the backbone of the paint, that's what's going to determine your primary physical and chemical properties of the finished paint system. You've got pigments, that's going to impart your color and your aesthetics, but they do also help with corrosion and performance as well. Solvents, the paints we use in this industry are solvent based. So we just use those solvents to keep it liquid enough to get up on the coater and apply it and handle it in a reasonable way. Those solvents, like I said, are burnt off and consumed in the oven during the painting process. And then there's additives, which is a very small component, which is to fine tune certain performance characteristics, whether it be flexibility, hardness, UV protection. We'll throw some additives in. Next slide. So again, this is a breakdown and sort of what they're bringing to the table, if you will, what their contribution is. And you can see that the resin or the polymer really brings the most to the table, right? Durability, your hardness, flexibility, adhesion, gloss are impacted by the resin. Your chemical resistance, corrosion resistance, humidity, abrasion, impact, all comes from the polymer. And then your pigments, of course, aesthetics and color, but they're also hiding the surface that you're painting. They also impart some corrosion resistance. They give the film some strength, and they do contribute to water resistance as well. And again, the solvents are really for those of us on the application side, right? The viscosity, how that paint flows out, how stable it is long-term in the drum, controlling film. That's all important, but once it gets out the door, there's no solvent left. Next slide. And again, this is just a little breakdown on sort of the balance of those items. You know, the resin, solvents, and pigments are pretty equally balanced out, and then the additives is a very small amount, and that's by weight, not volume. Next slide. Okay, so how do you know what paint, right? There's a lot of paints. Even in the household world, right? You walk into Home Depot or Lowe's and you're overwhelmed by the amount of paints that are in there, and it's a little bit the same in the coil coating world. So you need to balance. So what's the end product? What does the end product need to do? What kind of environment is it going into? Is it exposed to the outdoors? Is it indoors? And then you got to balance all of these ingredients to get that performance, but also have a product you can handle and apply on the line. So, our paints tend to range from very soft to very hard and brittle, right? So on the left-hand side here, you're very soft, very flexible, paint system. Maybe it has to do really tight bends. Something that comes to mind is T-bar, ceiling T-bars, right? That's all coil coated. It has to be a very flexible paint, but it's not ever going to be outside. So it doesn't really need good UV resistance. It doesn't need to have a long-term warranty as far as color and fade. And then as you move to the right, you get a little bit harder, more brittle film, but you need it to be flexible enough to make panels. It needs to resist chipping and scratching and marring out in the field while it's being handled and installed. So most of your high-end architectural coil coatings paints fall sort of where that red bar is, a little, more to the right of center. Next slide. So pigments and color, what do they do? Well, right, they make things pretty. We like that. We like how it looks. So they're insoluble solid particles, finely ground and dispersed and wetted out onto the resin of the polymer of the paint, which is very important. That's what gives you your nice, even, consistent color. There's two kinds of pigments in the world, organic and inorganic. Your inorganic pigments are your more earth tones, your duller yellows, reds, greens, browns. They're usually iron oxides or some other kind of metallic oxide in nature. Organic pigments are your very bright primary colors, your vibrant reds, blues, greens, and violets and yellows. The problem with them, although they're pretty and they make really nice, pretty colors, is they don't hold up real well out in the real world, right? We've all seen faded red cars, that are now pink, bright blue things that are now baby blue. So when we're formulating these architectural coatings for exterior use on roof panels and siding, they're almost always all inorganic pigments incorporated in. You might use a little tiny bit of organic pigments to get the right shading and coloring that you want, but there won't be very much in there because it won't be warranted. Now, if you do need a very bright primary color, which does occur once in a while, a few examples would be, Home Depot orange. That is a coil-coated product for their signage. It does have to have a clear coat to protect it out in the sunlight. Next slide. So then color, like I mentioned earlier, we do control, controlling color is huge. You don't want any variation on job, right, on the final installed product. A lot of jobs are phased, multi-phase, multi-building, so the coils for those jobs might be run at different times. They need to look exactly the same from run to run. So the paint suppliers and then the coaters have a lot of things in place to control that, keep that consistent. But one is the use of computer software technology to actually numerically measure color more tightly and better than the human eye can. So we use like an LAB number, which is your light dark, your yellow blue, and your red green. And we do test that in production to a master standard every time we run to make sure we're not deviating. Next slide. Okay, so I think we'll stop here and take questions real quick before we jump in.
Hi, Michelle. We got a couple of questions, one from one of our attendees and then my own curiosity. Rob is curious about how do you deal with steel that's cut or slit after it's pre-painted when you get a raw edge? Can these cut edges be coated in the field?
It's an excellent question, and it's something we deal with all the time, right? Is you do have to do field cuts. So our recommendation is that you hide that field cut if you can, right, with either some kind of cap or flashing or something. But if it's going to be exposed, there are some air dry clear coats you can buy out there to seal that edge. The problem we've seen with those is that they tend to not weather as well as the factory applied paint, and you get sort of this blushing or cloudy look on the end of the panels over time. But if you have a good substrate, a good metallic, like the Galvalume, even on that cut edge, unless it's a severe corrosive environment like marine, you're really not going to get much corrosion over time. It should hold up well over time, even on a cut edge. And now the cutting is important, and there's a lot of technical bulletins out there on the best tools and technique to cut this product in the field too. So that's important. But if you get a good cut, if you can't hide it, it's probably best to just leave it as is rather than try to apply some kind of field paint, because you will get differential fading over time with it.
Thanks, Michelle. I got one question. Could you briefly revisit the different types of metal substrates and their advantages, disadvantages?
Absolutely. So the three most common, of course, are aluminum, galvanized, and Galvalume or zinc aluminum coated if it's a generic product. So aluminum is aluminum, right? We know it has great corrosion performance. It is probably the recommended substrate if it's available for marine applications, corrosive environments. However, there's a trade-off, right? It doesn't have the structural performance of steel. So, you know, depending on the type of application and the design it's being used in, it may not be feasible. You may have to go to such a heavy gauge of aluminum that it becomes impractical and cost prohibitive. So then you're down to coated steel. Galvanized, hot dip galvanized is 100% zinc coating. It's been around, you know, for, you know, over a century or two now. Well understood. Zinc is a sacrificial barrier on that steel. It will sacrifice itself to protect the steel. It's a good product. It's been around forever, been used in construction for a very, very long time. However, with the invention of Galvalume or the zinc aluminum coating, we took a big step forward in corrosion protection. So by adding some aluminum to that mix and getting an aluminum zinc mixture on the steel, you have a lot more protection for corrosion and a much longer lifespan out on a building. I think the Galvalume right now, they're getting service lives of 50 to 60 years. It's actually outperforming the other components on the building. You know, the galvanized fasteners are failing, but the Galvalume panel still looks good, kind of scenario. So that is really the substrate of choice for high-end architectural installations. And it's also the steel product of choice for marine environments because it does hold up very well. And I'll do a shameless plug that there is another course webinar that Paul hosts that is on the that Galvalume product specifically. We dig into why it performs so well and how it compares to galvanized. So if you get a chance, tune into that one because we dig in deeper.
Well, I appreciate that, Michelle. In the interest of going forward, let's. I've got a couple more questions, but let's continue on, and we can hold these till the end.
Okay.
Thanks.
Okay, so common paint systems and their differences. Next slide. Can you name the 3 common paint systems used in building applications? Next slide. So the 3 we deal with are polyester, silicone modified polyester, and fluorocarbon, also known as Pvdf, also known as Kynar 500. Also known as Hylar 5000, because the industry could not decide on just one name for that paint system, so we have 5 or 6 to confuse everyone. But there are 3 main paint systems at the end of the day, and we're going to talk about what they are and how they're different. Next slide. These are sort of listed in, you know, good to better here in this order. The fluorocarbon, Pvdf, Kynar 500 is what you will most commonly see specified in big architectural projects. It is the Cadillac of the paint systems. But the polyesters and the silicone modified polyesters certainly have their place in the world and bring their own attributes to the table that are good. Next slide. So polyesters. Really diverse chemistry here, really diverse paint system. And I always like to share with people how diverse polyester chemistry is. And I promise I'm not going to make you do any chemistry. There won't be a quiz on this. But, you know, think about our clothing we wear that's polyester fabric. And then we have polyester paints on buildings. It's the same basic chemistry. That's how wide-ranging this polymer work can be. They're very cost-effective. They have incredible flexibility, but also good hardness. They come in a huge range of colors and gloss options. You can get very, very high glossy finishes, very low gloss finishes as well. Very versatile. The most versatile paint system in the pre-painted market. We see these used a lot in gutters, downspouts, light agricultural, light commercial, appliance wrappers. Almost all of your appliances these days have a polyester coating on them. Interior stuff, door frames, window frames, closet tracks, you know, bath and shower components that are pre-painted are all done with polyester. Next slide. Silicone modified polyesters are what they sound like they are. It's a polyester backbone that's been modified with some silicone. And what happens when you do that is you get a step up in exterior performance. So you get better weatherability, you get better resistance to shock and fade. Again, like their polyester counterparts, a wide range of colors are available, a range of glosses are available. It's a little bit lower cost point than the Kynar 500 fluorocarbon technology. So we see the SMPs used a lot in light commercial and heavily in residential sidewall and roofs, are probably the most common applications. Next slide. And then the fluorocarbons with all its various names out there, right? This is the top guy. It's the top performer, exceptional chalk and fade, resistance to aggressive weather elements, great chemical resistance, excellent formability. And we see this on, big commercial applications, architectural, monumental type building where you need superior weatherability. This is also going to be the go-to system for harsh environments, industrial, marine, acidic environments. It holds up very well to all of that, so we use it there. Just by comparison, so the fluorocarbon chemical structure, the atom of fluorocarbon, is only one molecule off from Teflon. So it is a very closely related cousin to Teflon. A lot of people can wrap their head around that, right? We know how great a product Teflon is, and it's on all of our cookware and whatnot, and how durable it is, and it stands up to heat and repeated use. This paint system is its first cousin. So very similar properties at the end of the day. Next slide. So again, a little cheat sheet here to break these three down. The polyesters, right, they range from good to better. SMPs are better, Pvdfs are the best. Price points, again, cost effective to moderate to high. Warranties, the polyester warranties are a tough one to answer because it ranges anywhere from none to, I've seen 25, 30-year warranties on polyesters, depending on what kind of pigmentation they're using. The SMPs are long, 25, 40-year range. Pvdfs are 25 years and up. I think there's 40-year warranties out there now on the Pvdf system. And again, the durability, good, better, best scenario. The applications, right? Polyesters, wide ranging, a lot of interior applications and non-warranted products. SMP and Pvdfs are going to be your exterior products that need a warranty, it needs some kind of performance. And the only downside to the Pvdf I would mention here, we don't have it listed, but really hard to get high gloss in the Pvdf. The resin itself is actually a milky white color, so you have to formulate around that for color in the lab, which is a challenge. It's hard to get really high gloss products out of it. And then we've got the AMA specifications that are appropriate for each one of these paint systems. Next slide. So considerations, right? Again, not all polyesters are the same. So if you're working with polyesters or someone has specified a polyester, make sure you're getting the right polyester for your application. The Pvdf is still the best UV resistance out there on the market. It's going to have the best exterior durability. The Kynar 500 and Hylar 5000 name are trademarked names for the Pvdf system. The paint companies that make these paints must have a license for Kynar and Hylar to call their product that, and it must make up at least 70% of the overall resin composition in the final paint, and that is tightly controlled and monitored. So some restrictions around how that chemistry is used out in the field, and the suppliers of Kynar and Hylar do randomly sample product to test for that. Next slide. Okay,
Michelle,
so yep.
We've got a couple of questions here,
Okay.
if you don't mind. Michael wants to know what's the order of magnitude cost difference between SMP and Pvdf. Is Pvdf 10 times more expensive than SMP, twice as expensive?
I have a hard time answering that because that final cost into the market is from the panel manufacturer, right? So I can't talk in percentage. I would say you're probably looking at, I hate to be quoted on this because it's not my area, but it's not going to be 10 times. It's not going to be 100% difference. I mean, you're probably talking 25% or less difference. On the front side, for those of us who are applying the paint and have to buy the paint, the differential is big. The price per gallon difference is large. But by the time you've applied it to a coil and the coil gets formed into panels, you're looking at, you know, it's probably not more than $1 or $2 per foot. It may be less than that. It may be 25 cents a foot difference for the paint system. So that differential on cost per gallon gets minimized as it moves through the supply chain greatly.
Thanks. I have another question about the difference between Pvdf and Feve Lumaflon, and I have that curiosity myself. Is Feve just a proprietary name?
No, so Feve it's in the same family as Pvdf, right? So it's very closely related. It's a clear liquid resin as opposed to a solid milky white resin like Pvdf. So it has superior performance. It really is a top-notch product. It is very, very expensive. Like that cost differential is definitely felt even downstream on finished panels. It comes at a huge premium. The advantages of it is that it does allow you to get the higher gloss if you want a really glossy finish. It can be used in semi-transparent applications without a primer underneath it and does well. I mean, it may not have a 40-year warranty, but it does well without a primer. And it does come out of the automotive clear coat world. So yeah, it is very good technology, but it's a little bit of a step up from Pvdf in some respects, and it's a big step up in cost. I mean, I can talk about on the paint side. Again, I can't say what panel manufacturers are doing on their costs, but an Feve paint is easily $200 a gallon or more in cost, versus a Pvdf that's probably $75 to $100 per gallon, if that. So it's a big step. But it is very good technology. Lends itself to some very specialized uses.
Let's keep going here. There's a lot of great info we don't want to miss out on. So
okay,
fire away.
Enhancement options. So what else can we do? Next slide. So what are some important building considerations that influence the type of pre-painted metal that you might specify or see specified? Next slide. This is just a few. Proximity to salt water, that's a big one, right? We know that's corrosive. Building energy efficiency is important, desired colors and aesthetic looks. How visible is the roof, right? Is the glare off of it going to be a problem for surrounding neighbors or other installations? So that reflection off the roof is important. What other materials do you want to use in the design? And are they compatible? Is it going to be problematic with coated steel or aluminum? You know, are the eaves exposed? Is the backside of the panel exposed, or is it covered, etc.? We could probably do a whole webinar just on these topics, but we're going to dig into a few of the most common ones. Next slide. So these are the most common enhancements we run into day in and day out. Micas are metallic pigments, right? These are your sparkly pigments to get that sort of sparkly metallic look. That's very common, very popular. Most panel manufacturers have a copper or a silver in their lineup as a standard color. Clear coats. Do you want added depth? You know, is it a marine setting? You need that clear coat for corrosion protection. Is it an area that's going to be heavily abraded by flying sand? So you need a clear coat. We see that on military installations. It has to have superior abrasion resistance. Graffiti resistance. There are graffiti resistant coatings available that you can get. Cool roof for energy efficiency. Textures, right? Textures are becoming big. We're seeing a big move to those. Gives it a different look, makes it look like a more natural product rather than that shiny metal finish. And then prints and imagery that can be done in the pre-painted process as well. We can do wood grains, you know, faux patina looks. There's even some lines out there that are printing actual pictures and imagery on steel and aluminum. Next slide. So, right, the micas pigments, right, have that pearlescent, shiny finish. They're added to the paint just like any other pigment would be. Back in the day, we used to use metal flakes, but those weren't very durable long-term, so everyone sort of moved to micas, but the industry still calls them metallics. It's a holdover, get a sparkling and light-catching effect. This is also where your shifting color pigments come in, are part of the mica family. So you've probably all seen cars. You don't see it on buildings as much, but right where the color changes as your viewing angle changes, you get that shift in color that comes from these kind of pigments. Next slide. However, a word of caution with micas and metallics. They are directional in nature. So the way they lay out on the strip and then the way they get installed affects how they look visually. The orientation of these pigments, we can't really control them in the application process. We don't know how they're going to lay out. So you can't mix batches. You got to be very careful that you install them the correct way. So the examples here, especially the one on the left, is really obvious. That is panels run out of the same coil, produced at the same time, but they flipped those panels 180, and that's how different they look to the eye. So bit of a caution there, but beautiful look, very popular. We run a lot of these. Next slide. Extreme environments, right? Pre-painted metal can be modified for certain environments. Coastal and industrial being the two most common. Usually what we do is we beef up the primer on these systems and apply clear coat to give some extra protection. So now instead of maybe a 2-coat painted system, there are 3 or 4-coat painted system. But you can get a warranty if you do this. Obviously, I work for a West Coast based company. We do a lot of coastal installations, so we see this a lot. Next slide. Clear coats and graffiti resistant. There are clear coats out there that are graffiti resistant. Very hard to get anything to stick to them or to stay on very well. And then they're very easy to clean with some common cleaners. So metropolitan areas, that's something we're seeing a demand for. Clear coats can also provide additional UV fade resistance. Like I said, if you're using a bright primary color that needs some extra sunscreen, as it were, you put one of these clears over it. Also gives a little depth and can change the gloss and final appearance. So once in a while, we see architects wanting that for aesthetic reasons. And again, added hardness and moisture resistance. There's also antimicrobial systems out there as well for like walk-in coolers, medical facilities, food preparation areas, things of that nature. Next slide. Only caution on clear coats is that they're not completely 100% clear. If they were, they wouldn't have any UV durability, so they have some transparent sunscreen particles mixed into them. So it does yellow the base color a little bit. You really only see this on light colors. You won't see it on the midtones or the darker colors, but I've got an example here. If you move left to right, 2-coat standard system to the left, middle system is high build primer with no clear coat, and then on the right is high build primer, color coat, and then clear coat. And you can see that the white has shifted a little bit visually to the yellow side. This can be formulated around. The base color could be tweaked to hide that, but we find that most people are fine with it. They're more concerned about getting warranty and performance than dialing in that light color. Next slide. Backers. Often an overlooked item, but the back side, the underneath bottom side of the strip, the coil, when we're painting it, is painted as well. It's typically not seen, but we still want paint on there for a couple of reasons. One, it helps with corrosion and performance. It also helps when the coil is rewrapped after the painting process. If you just had bare metal on the one side against the painted top coat, you might get scratching, marring, and damage to that top surface. But by having it painted, you eliminate that. And then again, there are applications where that backside is viewed, right? Metal buildings, pre-engineered metal buildings, you can often see the backside of those panels when you're inside the building. Overhangs and eaves, you can see that backside. So it's usually like an off-white or a light gray color, but we can fully coat whatever color you want on both sides of the strip. That is something that most coil coaters can do. If you want a double-sided finish, all you got to do is ask. Next slide. Cool colors, right? Cool colors came on the market about 20-something years ago. They are designed with infrared reflecting pigments. So these pigments were a huge development in our industry, right? They were able to chemically and physically alter the pigment structure itself to better reflect IR wavelengths, which is what generates heat on a surface, but also able to keep the visual color the same to the eye. So this allows us to do darker colors that stay cooler than their non-cool counterparts. Any paint system can incorporate cool pigmentation. It drastically minimizes heat buildup and reduces cooling costs in hot climates. It also helps lower the heat island effect that we get in metropolitan areas. So I would say now that most panel manufacturers and most of the paint companies have gone to this pigment technology as a standard. You usually don't even have to specify it anymore, but it's always good to check and make sure that that's what you're getting if you want it. Most panel manufacturers on their color cards will state what their reflectance values are and whether they're using cool pigments or not. So you can check that. Next slide, I think we have an example of that. So yeah, so here's an example of someone's color card with the color name. The SRI is the solar reflective index. That is a calculation that's done between solar reflectance, which is the amount of solar radiation reflected off of it, and its emissivity, which is how well a surface dissipates heat, to come up with SRI. Higher the number, the better for energy performance. These are reviewed and monitored by the Cool Roof Rating Council as a third-party certifier. So you can go to the Cool Roof Rating Council website and look up all kinds of roofing products to see if they've got their blessing and what their SRI value is. But unlike other materials, metal really has an advantage in this arena. So these paints, as we just talked about, are formulated to last so long and are so durable that we get very little drop in color and performance over time, versus say like an asphalt shingle, single ply membrane type applications. Field paints fade pretty quick. So, you know, we can go like 20, 30 years and have very little, if no change in the solar performance of this product out in the field. Next slide. So again, LEED, right? If you want LEED credits, you've got a LEED project. They have specifications around SRI and about cool roofing. Low slope, it's got to be 82 or higher. That really limits you to whites and off-whites. But steep slope, you can go down to 39. So that does include some of the mid-tones. You're probably not going to be able to do a black and meet that, but you can do some of the darker and medium colors. So it gives you some options there. Next slide. Now, this is where things get a little confusing. So we have solar reflectance, and then we have light reflectance. Solar reflectance is about reflecting heat and infrared radiation. Light reflectance is optical, right? That's what we see with our eye. It's the shininess, the glare off a surface. And this is becoming really important. I think in the last probably 5 to 10 years, we've seen a real move to low light reflectance, right? And some building codes are incorporating this into their building codes. They don't want things to be shiny or glary. It is expressed as a percentage from 0 to 100. Typically, light colors will have a higher value than dark colors, but not always. Texture impacts this, pigmentation impacts this. But you know, the rougher the surface, the more you disperse that reflection and it looks duller, looks more matte. We are seeing a move to this in the industry. It's been around for a long time around airports and military installations, right? You don't want to blind a pilot who's trying to come in for a landing, right? So you got to have very low light reflectance off of any of the buildings in the area so that they're not affected negatively. Next slide. And then we talk about gloss and sheen. Again, it gets a little confusing. Light reflectance is just how you view an object and the amount of light, that visible light that's reflected back. Gloss and sheen is how much light is reflected back at a specific viewing angle. So gloss is a 60% viewing angle off the surface, and sheen is 85%. High gloss, high sheen, you will get a lot of glare. It'll have a high reflectance value. If you go to a low gloss, low sheen, it's going to have a very flat or matte appearance and a very low light reflectance value overall. Next slide. And again, the textures, right? So the best way to get your gloss, sheen, light reflectance down is by adding texture. And this is done in the paint chemistry. A couple different ways. It can be either a physical particle that is added to the paint to give it a 3D structure, or it's a chemical reaction. So the paint goes on smooth, but in the curing process, as it gets hot, it wrinkles up or gathers up and makes this rough surface. And we are seeing more and more of this. Next slide. Prints, patterns. another enhancement that can be done. So we can do more than one color. We can do roll printing. These rolls are etched or carved in a pattern that we put the paint on and then apply it to the strip. It's the same paint systems that we use to do regular solid paints. It's either Pvdf, SMP, or polyester. It can be developed and customized pretty short time period. The one downside is you are going to have a repeat, right? We can only get our rolls so big on the line, so you will have a repeat of pattern, but we work very hard to minimize that, so you don't really see it in the finished product. Great application for exterior. You get a brushed look, you get a patina look, you can get a wood grain look. We even have done camo prints for like hunting blinds. We've run that. Next. There's some of the printed, right? So these are laminates and digital printing. I see a lot of this coming out of Asia. Very decorative imagery. It's the laminates. It's actually printed on a film that is then bonded to the substrate. You get rid of the reproducibility, but doesn't have quite the same performance as true pre-painted product. That bond is not very strong. But we see a lot of faux wood, faux stone imagery, mostly for interior applications, not so much for exterior. You might see some garage doors work done with this as well. It's out there. Digital printing is similar. They're giant digital printers like we would use for paper or something else that can print on metal as it's running. And large scale versions of that. That technology is really gaining some momentum right now. They finally figured out how to print at, a line that runs 500 feet a minute. That was always a challenge in the past, but they are doing it now. Next slide. Okay, should we pause real quick? Any questions on that?
Thanks, Michelle. We've got just a couple of questions here. One from a little while back from Sergio, who's asking about whether you would recommend painting stainless steel and why, yes or no.
You can pre-paint stainless. Couple things. It's we always sort of scratch our heads and go, why would you coat over stainless? Because sort of the point of stainless is to use it as stainless steel. But it can be painted. It's a very expensive product to get manufactured. We see stainless mostly for food preparation, medical, pharmaceutical installations. And that what they do is they actually leave one side bare. The side that's actually going to be in contact with medical stuff, food stuff inside the building is left as bare stainless. But we paint the backside with an adhesive primer so that they can insulate it. We rarely see fully painted stainless because I think there's just not a need for it, and it's so costly at the end of the day.
Thanks.
But
Let's continue on because we're running shy on time, and thanks.
Okay, next section, pre-painted metal durability issues and warranty coverages. So what are the 3 common elements warranted for this product? Next slide. 3 things that are usually covered in a warranty. The metallic coating, corrosion performance, if it's the aluminum zinc product. And when it comes to the paint, that's going to be film integrity, which is, is my paint going to stick long term and stay on the metal? And then chalk and fade. And we will talk about these in a little bit more detail. Next slide. So these warranties can be anywhere from 5 years and up to 40 years. There's some 50-year warranties out there. Pre-painted typically warrants for excessive chalking, which is sort of that white fade that you get on buildings, excessive color fade, and then delamination of the top coat of the primer. Why a product might fail can vary a lot, right? It can be due to improper application. It can be an installation issue. It could be a bad paint formula. Maybe the coater didn't get the right amount of film on there for some reason. It could be environmental conditions that are outside of the warranty. So we talked about the different paint systems. You do see a lot of difference between the warranties, and got an example here of that. This is the same color initially went out. They did a Kynar 500 acrylic, a polyester. in a silicone polyester system, all in the same color. Actually installed this on a steel company in Japan, and then, you know, checked it a few years later. And you can see that the Kynar, the Pvdf system is looking the same as it did when it was installed. The SMP is starting to fade a little bit, but not so bad. But the acrylic and the polyester are really degrading over time. Next slide. So what is chalking? It's just what you think it is. It's a chalky surface that's after exposure. So it's a degradation of the resin system. So that polymer resin backbone starts to break apart into little pieces because of exposure to UV. When that happens, it can now come out of the paint surface, bringing pigment with it. So you get this white appearance. It's caused by UV. I rarely see this anymore. Even in polyesters, the formulation work has gotten so good, the polymer technology has gotten so good that we rarely see excessive chalking anymore, just few and far between. There is an ASTM test to measure it. You don't use just your hand. There is a way to measure it out in the field. Next slide. The really big one is color fade, right? You buy something, you want it to look the same color for as long as possible. Same with our cars, anything else that's painted. You know, again, this is UV breaking down the pigment particles that are in there and changing their color. It is measured numerically by a delta E measurement that represents total overall color change. The human eye can start to see color difference around a 0.5 to a 1 unit delta E and above. The Pvdf systems warrant the smallest color change. It's typically 5 units or less for whatever the duration of the warranty is. And I wish I had better photographs of this, but there's some examples that show initial color on the top and then fade as we move through 5 units and then 7 units of color change. So it is perceivable, but you know, if your house is 30 years old and you've only got 5 units of fade, you're probably not going to be too upset, or your building. The other thing that's important too is that it fade the same and consistently. So I've got a picture there of what we call a striped roof. This is actually a roof where they mixed 2 different paint systems that were the same color. And the panels that still look good there, sort of in the middle left, were Pvdf, and the rest of the system was polyester, and they are fading differentially. So that's why it's important not to mix these paint systems too on an installation. Next slide. Delamination, or lack of film integrity. So this is when the paint is coming off for some reason. This is a really tough one to troubleshoot out in the field because it can have a multitude of root causes. It creates a visible bubbling or peeling of the paint. Sometimes it's between the top coat and the primer. Sometimes it's all the way down to the substrate. The most common reasons for this are low film during the application process, incorrect pretreatment being used on the strip, maybe the curing time of the paint wasn't right, or an incompatibility between top coat and primer. Can also be caused, there's a little cutoff on here, it can also be caused by, and this is the most common one we see, but it's hard to prove, mechanical damage during installation. So the panel gets scratched up, they don't correct that or fix it, you now have an opening in the coating that over time, water and moisture and stuff can get in there and starts to lift that paint up. You'll notice on this example on the right, there's some very straight vertical lines where that paint is peeling. We concluded that this was most likely scratching during installation that resulted in this. Next slide. So other avoidable failures. Dissimilar metals or incompatible materials being used. Dissimilar metals is the big one, especially in coastal applications, because you get galvanic corrosion. You know, the wrong sealants being used, direct contact with wet concrete is a problem. Swarf or metal filings being left on a panel and not cleaned off. Those little filings are going to rust eventually and leave staining on the panel. Wet stack or storage corrosion issues are a big concern in our industry. This stuff will corrode prematurely if it's left in bundles or stacks without airflow for too long. So you got to get it up and installed pretty quick. And then we also deal with oil canning, which isn't really a failure and it's not warranted, but it is something that light gauge steel is prone to. This is a complaint some people have about using metal, is you get that buckling or wave in the panels, but there are ways to counter that. Next slide. So dissimilar metals is our big one, right? This is two different metals in contact with each other in a corrosive environment, and you're going to get galvanic corrosion. So the more noble metal, the less active metal, is going to be protected by the active metals it's in contact with. Proximity to the ocean is a big deal because it's a corrosive air and water environment, and it can be quite severe. So on the galvanic chart, the further away two metals are on the list, the greater this potential exists. What I have here is an example of a Galvalume painted panel with a stainless steel lighting canister recessed through it with no barrier between them. And all of that staining and corrosion you see around the lighting canister is the Galvalume panel sacrificing itself to protect the stainless steel. Now, if this wasn't near the water, near the ocean, wouldn't be a problem, but because it's in a saltwater environment, it's a huge issue. This site was about 300 feet off the surf break in Southern California, so high salt content. Next slide. These are some other examples, right? So the Galvalume, the aluminum zinc steel, cannot be in direct contact with concrete. The water and the moisture that it holds will corrode that aluminum and that zinc mixture pretty quickly. An example there at the top where they did a concrete pour up against the panels without putting a barrier between them, and you can see all the paint's bubbling and lifting off. That is because underneath the paint, the panel is corroding, the steel is corroding. So that's a problem. Chemically treated wood is another one we encounter. So chemically treated wood usually uses some kind of copper mix or copper chemical to treat it. That copper can leach out. It's incompatible with galvanized and Galvalume products. And if it's allowed to drip or run onto the painted panels, it will cause premature corrosion. An example there is a wood deck that had was chemically treated, and that's just running off onto the metal roofing below it, causing issues. As soon as you got out from underneath that deck, the panels were fine. Next slide. So our swarf we talked about, these are metal filings that get left over from drilling, cutting on the job site. There are a lot of technical bulletins on this and how to avoid it, how to clean it up. And this is really on the installer, right? That they do, first of all, you should be cutting and drilling away from other metal panels, clean them and then install them. But if they're left on the surface, you do get these red stains. And it always comes in as a claim of, hey, my roof is brand new and it's already corroding. Well, it's not corroding, it's something on the surface that corroded and then left a red stain, which is very, very hard to remove after the fact, almost impossible actually. So got to cut properly, got to clean up afterwards. Next slide. Wet stack corrosion or storage corrosion. This is oxidation that occurs due to transport or storage in a wet environment. So if there's no airflow and water gets between these panels when they're stacked, it causes the substrate underneath to start forming an oxide product, which then pushes the paint off of the surface. So there's a lot of information on how to store properly to prevent this out there in the industry, both at NCCA and most of the panel suppliers have technical bulletins on the best way to store product. So the Galvalume product tends to hold up a little bit better than galvanized to this, but if conditions are right, if it's humid and warm and there's moisture, this can happen within a matter of, a few days or a week out in the field. It's a big issue. Next. Oil canning. So it's not a paint failure, but it is something that light gauge steel is prone to, especially in flat profiles. You get that wave or buckling in the panel. It can be caused by stresses in the base material. It can be improper fastener pressure and location. It can be misaligned panels. It can just be normal thermal expansion and differential movement between the structure and the metal panels themselves. The way to avoid this, make sure you're getting tension leveled material. Add stiffener beads or striations. If you're doing long length, anything above like 10, 12 foot spans of panels, probably want to put some striations, can emboss the surface. Low gloss coatings actually minimize this look too. It's still there, you just don't see it as readily. And I love this picture on the bottom that we got recently. This is on the same roof with and without striations. So you can see the difference it makes in how those panels look. Gets rid of that buckling. Next slide. So how do we avoid these failures, right? You want to have the right paint system and the right substrate. Make sure you know the environment it's going into. Make sure that the coil coater is reputable, knows what they're doing. Don't mix batches, don't mix paint types. Make sure you get a good panel manufacturer who packages correctly, stores correctly, has good installation guidelines to put out there. Make sure that the installer has worked with metal, knows metal, understands the pros and cons of it and how to avoid issues. And then cleaning and maintenance is important. You do need to wash this off. It's like your car, right? If you never washed your car, you wouldn't expect the paint job to hold up. So similar with metal roofing and wall as well. Next slide. And then this is I think we're towards the end here, but this is the constructs of a coating warranty. Make sure you read them. People get a little hung up in headlines like 40-year warranty. Well, but what are they warranting for 40 years, right? Because we talked about maybe that color fade, maybe they're allowing for some huge color fade in 40 years, or maybe it's tight. You got to read through the details. You need to read the exclusions to make sure there's not going to be any issues. But yeah, don't get caught up in the headline of the duration. Read into the details. It's a little boring, but it's worth it, especially around marine exclusions and industrial exclusions. People often buy a product, install it, and then read the warranty and find out that they're not getting a warranty because they sit close to the shoreline. So make sure you do that up front. Next slide. Again, everything I just said. And a little tidbit I like to leave people with, again, a comparison to the car world. I talked about how thin our coatings are versus cars, how quickly we paint it versus cars. And we have these warranties that are 20, 30, 40 years on a building that is exposed to the elements 24/7. Your average car warranty is only 7 to 10 years. Most people are a little surprised to find that out, right? Automotive coatings are held up as the end-all be-all of coatings, and they have less warranty than what we're putting on buildings. They get constant exposure. So it's a real testament to the chemistry of the paint systems being used in pre-painted metal. I think we're at the end. Any questions? Has anyone left? Has anyone stuck it out with us?
Yes, we have quite a number of questions, and the audience is with us. Thanks very much, Michelle. What a great amount of content there. Let me, in the interest of time, first of all, if we don't get your question answered, you can follow up, and I'm sure Michelle will be happy to answer any questions. You'll get her email, her contact tomorrow in an email. But right now, got a question about can you get wood grain look with the energy efficient coating?
Yes, absolutely.
Okay, and that's just the coating issue, nothing else. It's just easy to do.
Yeah, it's just the paints that you use. And like I said, almost all the paint suppliers have gone to using that cool technology as their standard. Okay. It's rare to find it without.
And the other question, another question here, will thicker gauge metal make a significant difference in reducing oil canning?
Yes, the thicker, we do recommend that too, right, is increasing gauge. And then, yes, that does help, right? So going from like a 24 to a 22 or a 22 to a 20 gauge does help oil canning typically.
And the final question here before we depart, how much overall steel demand, galvanized, et cetera, is for painted steel? Is it 20% of the steel demand is for painted steel?
I can only, I can only talk to our business. It's at least half, if not a little bit more, especially the Galvalume substrate. The Galvalume Zincalume substrate was designed and developed to be a pre-painted product. So we see the majority of that getting painted. Now, galvanized, there's a lot of bare galvanized usage out there, right? HVAC and rainwater goods and other things besides roofing and siding. So, but I would say it's at least half on average. Fluctuates a little bit year to year, but a lot of it's pre-painted.
Great. Michelle, thank you so much. What fabulous content, and I'll encourage everybody in the audience to follow up. Sorry about the rough start there.
Yeah, my apologies.
Everybody loves to get the blue screen of death. But thanks so much for sticking with us. If you guys want more information, you can go to steelscape.com, and a reminder that the AIA reporting and certifications are going to be handled automatically, but please allow 7 business days. Tomorrow, you're going to receive an email with links to more information, including, I believe, Michelle's email address, so you can follow up with questions for her. And also, there will be a link to a recording of this webinar if there are particular details you kind of want to listen to. Again, there's a ton of content here. Thank you all for attending. We're going to do another webinar on May 20th, Metal Roof Systems Design and Installation Considerations, and it's presented by AEP Span. And you can always find the latest information about the Metal Architecture webinar series on our website at www.metalarchitecture.com. Michelle, a great presentation. Thank you so much.
Oh, thank you, Paul. Appreciate it. Have a good day, everyone.
All right. Thanks, everybody.